Our next speaker is Son McCarthy. He's a very smart guy. He's living in Canary Island. Okay. And we have been talking about security, and he will explain why it's so easy to take the information in internet. He will speak about protocols, but he has promised to be not technical at all. Thank you, Son. Let me try to open your presentation. It's here. Okay.
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 Hi. Okay. No, it's fine. Thank you. Hi. Thank you first. First, thank you for having me in the panel and having us to explain a little bit about security and show the protocol that we will be talking about. And it's interesting that the previous speakers have been talking about so much about IoT and talking about security, because this is it goes very well with the subject we're trying to explain. We've been working for a long time now in security, analyzing protocols with for customers and analyzing networks for them, helping them with their security and everything. And it has been for a long time that we've been working with it, and we've reached to the conclusion. We have got to the point that we know that the internet is not secure. Internet is not really secure, and it's not news, but it comes from one point that what we're really talking about. The internet was designed in the late 70s. All the protocols that we're still using are the protocols that have shared that same DNA from that time. And the problem with all that is that when they design internet, when they designed the TCP/IP, that is the basic protocol for internet, they were not having security in mind. They were not having anonymity in mind. They didn't have many concepts in mind when they were doing that. So the problem is that we've been growing with that technology. We've been still using it today, and the problem is that we have got all the problems that were related to it. What we have been doing for a long time is trying to patch all those problems with new security protocols, with firewalls, with IDS, with new tools, but it hasn't really solved the problem. We've come to the conclusion too that the problem with the network, with the internet itself, comes from a simple point: is that we are. This is the technical part that he was referring to, and I shouldn't be getting too much into, but is that where the service is used. I mean, the service, thinking about like a browser, or thinking like a movie player, or an app that is on our cell phone or anything, is on the point of the TCP, but the control of the network is really on the end point of the physical access. The problem with that is that who controls the communications now? Who is in control of the communications itself? It's not the network itself, the one that controls the communications. Is the user who controls the communications. Why is this a problem? Because if the user controls the communications, he can do whatever he wants. Has been good for some time for us, that we can do whatever we want. It has been good for things like anonymity, because we can anonymize our information in the internet, but it's for sure not good for security. For security, that we can control the communications is not good. So the opposite of this would be the POTS, the plain old telephone system. When we are talking about the telephone system, who is in control of both the service and the network is the telephone company. We cannot just say our telephone number is a different phone number. We cannot just change the way it works. We cannot change information in it. We cannot do anything. The telephone service is secure by default. And is in control of all the communications. I need a little bit closer, yeah. Thank you. What's fun with this? On the internet, insecurity is everywhere. Users can change their addresses, they can impersonate users, they can intercept the communications of other users, et cetera, and they can do all that stuff because the user is in control of the communications. The user is in control of what is sent, how it's sent, and everything. And the thing is that how do we try to solve the problem? How do we try to solve all these problems in the network? Well, just by using firewalls, by installing new software like encryption, using digital signature to encrypt the communications, and additional network features, and so on. So what we're doing is just adding more stuff on top of the protocols that we've been using over and over for all these years to try to patch, because we're not really solving the problem. We're patching the problem. We're just making one of the less problem just to find out that the result is that a new vulnerability appears. It's been said a few minutes ago that it's not if the device is secure or not, is that will be run or not, is when there's going to be a failure on the product. There's going to be a bug sometime. So it's not an if, but it's a when. So even after spending a lot of money, even spending a lot of time to try to solve all these problems, the result is that we find new problems. It's just like with the firewalls. We tend to think that the firewalls are secure. Firewalls are try to solve the problem about the not accessing the corporate network, et cetera, et cetera. But what we don't think is that when we are opening a firewall rule, or when we're opening a communication in the firewall, what we're really opening in is a way for the people to come in the network. Okay, we have to open it. If not, we will be disconnected. So what we're really doing is we're really opening a way for everybody to come into the system. So the firewalls are not really secure. It's just trying to patch the system. We're just putting a block road on some part of the network, but we're just leaving the rest open. So the hackers, what they will do is just, okay, I have a firewall here, I will just detour them the other way. So it's just a patch of the system. So the thing is that what we really need, what we really have to have is that we have to have a communication that must be and can be secure, simple, and more efficient. But to achieve this, we have to change the way that we are doing stuff. We cannot just keep doing the same thing. Like, well, the Henry Ford quote is that if I ask people what they wanted, they will tell me faster horses. And that's what we're trying to do, faster horses. We're just trying to do the same thing. So the thing is that we have to change the way that we're doing the things. We have to be disruptive with the network. We have to change the way that we're doing it. And how? Well, first we have to be fewer technologies. The more technologies we're out in, is just the more complexity we are in. If we look at the network today, we have routers, we have firewalls, we have IDSs, we have penetration systems, we have a lot of tools incorporated into the network, and we're going to even add more, like SDN, SDN on the WAN. We're going to add more and more tools to it. What we're just doing is we're increasing the surface of attack to the network. What we're doing is just increasing the complexity. We need more people to control it. We need more people to know exactly what's going on. And it's just like I said before, being a good technical person doesn't mean that you're a good security person. So most of the time, the people that manage these systems are not security experts. They're just technical people that they have a basic training on it, and they're trying to do their best, but don't foresee all the ramifications of the problems that they could create with this. So we have to be more simple in the way we are doing things. We have to not add layers upon layers of security and make it more complex, the problem, but simplify the problem. It has to, the network that we want, the network that we need, has to have security built in. TCP/IP did not have it. We have to add the security protocols afterward. So we have to work with a network that works from the get-go with security inside. And we have to do it, again, in a simple way in order to reduce the surface attack. So if we try to do the same thing over and over, if we try to do IP and add more stuff, well, Einstein said it before, much better. So what we really want is, well, that the network itself, is the one that manages the system. No more additional protocols. No more fake internet addresses. No more control from the user. The network has to be able to block the hacks. Has to block what is not permitted. Has to have firewalling rules incorporated into the network. Has to hide the network from the outside. Well, this might sound strange, is that, well, if we don't want someone to access the network, it shouldn't let that person have access to the network. Sounds pretty much like a firewall, but as I said before, the firewall just opens a hole and lets the people in. But to make all this stuff, you need a deep knowledge of how networking and how it works and how to modify and get it. So let's see how it could be, how it's done. And I'm just thinking, that they're going to tell me, well, this is a lot of technical, but just imagine that we have the example, of having someone download an iBook, from the store or something like that, from a server. Could be any application. So in the basic TCP/IP operation, what we do is just we get what we want the book to be sent. We get one page, we put it into an envelope, we put it in a package, we repackage it again, we get to the physical layer where we send it off to the network. In the network, it's unwrapped again, and unwrapped until the router knows where to send it and has to do all the operation again and again and again, and it has to go through all the network in the same way, passing router per router. And there's a lot of places where this can be attacked. There's a lot of places where this can go wrong. And all this routing happens with the information that we stated at the beginning, where we stated as users. So the network is just listening to what the user said. Okay, I'm this server, send this package to this user, and the network complies. And who said all that stuff? Who said how this package has to be sent, where to be sent, the way it has to be sent? Well, is the user who said it. So if we just keep doing the same thing over and over, we get the book transferred completely to the other end. Well, this is just TCP/IP, so we get the book sent, and at the end, the user gets the book and reads it. The end user doesn't care. The only thing he wants is to read the book, but the way we deliver the information matters a lot. With all being said, IoT and things, there's more and more devices get into the internet right now. There's more information being sent right now. There's more points of attack. There's more software running to be attacked, etc. So what can we do to change this insecurity, this way of transferring the information that is controlled by the end user, that is controlled always by who sends the information and who controls the information? Well, we've been working for some time and we think the solution is the UETS, the Universal Internet Telecommunications Service. This service is a patented idea by LM Data Communications, and is patented here in Spain. And the idea in practice is very simple. It's just packet switching, like the POET has done for a long time, but applied to the internet. The only problem with changing all these protocols and things like that is that normally things break, and people don't like the software to get broken. They want to browse their internet, they want to access a web page, they want to download their movies, they want to do the same thing over and over with their own applications. The providers don't want to change all their software, they don't want to change all their operating systems, they don't want to change all their hardware and everything for this to work. So the real key point about making this successful is to make it work with the existing TCP/IP stack and making it a progressive conversion. So instead of letting the user control the communications, we just switch to a network control communications. The network is the one that controls how it is defined. The network is back in control of how the information is delivered, is back in control how the information traverses all the network. It's not the user anymore. The user cannot impersonate another user. The user cannot say, I'm this other phone number, I'm this number. This is a radical post idea of what has been done up to now. But so before, if we just keep doing the same thing, we're going to get the same result. So the UATS technology, by packet switching, by switching, will work pretty much to the end user will be much the same. They will still have their TCP/IP stack. They will have all the same information, but all the information will be just Ethernet diagrams, end to end. It will be switched like in the telephone. So it will just work the same way, but instead of being package and repackage every time that it traverses a node in the network, it's just sent. It makes a circuit from one point to the other point. No more unpackaging and repackaging. The end points do not change nothing. They haven't changed their software. They haven't changed their computers. It just works. But if we want more security, we just skip altogether the TCP/IP stack. The operating system doesn't use a TCP/IP stack. We just send raw Ethernet frames from one point to the other point. So we're even more secure. There's no TCP/IP to attack. There's no more problems about TCP/IP. Still compatible with the TCP/IP. The applications don't change. The applications are not modified at all. It's just the operating system that knows how to deal with the information. Well, this sounds like, well, okay, this is, sorry, I skipped a couple slides. So the network, the key aspects will be circuit technology in other networks instead of packet switching. High security, there's no TCP/IP to attack. No problem with the TCP/IP. It's fully backwards with IP. So TCP/IP applications don't have to be recompiled. We still can get our browser, open it, type Google or whatever, and we'll still get to the same point. We'll still watch our movies on Netflix and so on. And we remove complexities instead of adding new layers, instead of talking about adding a new firewall, a new software solution, a new thing that adds to the stack, that gets into the middle or anything. No, this is reducing the problem. This is really actually taking off instead of adding more and more to the solution. So this has been said, okay, it's very, very good. Well, sounds pretty nice, but this will not work. It's not possible. You know, TCP/IP is going to be broken. TCP/IP is going to be problems. So for that reason, we have set up a proof of concept in Madrid, and we have working test bed where we have applications working with this new protocol with the hardware that does all the switching, and it just connects to the LAN. It connects to the internet. We have applications running on them. We have all the things working there. So it really works. This is not a matter of it's not just an idea. It's a real protocol really working on real scenarios. So we have the hardware. We have designed and developed the software specific for the protocol. So it's working for real. And well, apart from the security point, which is what we centered a lot, we're the key point for us. Internet of Things will need a lot of security. This is a perfect scenario for Internet of Things, because apart from also being very secure, it also is very efficient. If you look at it's very technical, but but it can be seen that, well, we're just skipping TCP/IP altogether, so we're obtaining communications much more efficient by not using all this stack of TCP/IP. And just this adds to the rest of the benefits of the system. So we think it's real time to change the way we're doing things. Internet has been very good for us. TCP/IP has been serving us for very well, but is a Model T. We really need to get the Tesla now. So we have to really upgrade the systems and go to a faster system, more secure system, something different that is really radical, but it really works. Thank you.